All right, welcome to the video here for lesson number 3 in Unit 9. So this is the second day that we dealt with the normal distribution and z-scores, and there are just two questions here in homework for us to look at. So the first question talks about these two different classes that a student's taking. One class is out of total points, and then one class is out of percents. And the two girls, Jessica and Anna, want to see who did better in the two classes. And you can't really compare them because they're out of two different ways. So the only way to compare them statistically is to do this using z-scores. So if I can figure out the z-score for Jessica's points earned and the z-score for Anna's points earned, whoever z-score is higher winds up saying that that student did better comparatively to her class than the other. So let's first talk about Jessica. So Jessica's z-score, so we'll call that z sub j for Jess, is going to be 729, that's her score, minus the average or mean score of the class, 675, divided by the standard deviation of the class, which is 50. So Jess's z-score, if I do 729 minus 675 and divide that by 50, is 1.08. Now, we can use that z-score to figure out a couple different things. So if I was to do a normal CDF, and start with the bottom number or the lower number as -10 and the top number as 1.08, I could see that Jess did better. Help if I spelled scored right. So Jess scored better than 85.9% of kids. So she's in the 86th percentile, we'll say. We'll round that up. So then we can find the z-score for Anna. If Anna's z-score is higher than 1.08, that means that she beat out more kids comparatively to her class, therefore Anna's score is better. If Anna's score is less than 1.08, that tells me that Jess did better because she had a higher z-score, so she scored better comparatively to her classmates. So Anna's score is a 90. Out of the class average of 82 divided by the standard deviation of 6, which gives us 1.3 repeating. So Anna is obviously going to do better here because she has a higher z-score, but we could find the normal CDF. So if I go into the normal CDF here, we see if I hit the right buttons, that would help. So if we make the lower number -10, the upper number 1.333, we see that Anna scored higher than, we'll say, 90.9% of kids. Therefore, Anna has a better score. When compared to her classmates, right? And the reason why is because Anna's z-score is higher, right? We'd want to say that in the problem as well. Number 2 says, suppose that the durations of high school baseball games are approximately normally distributed with a mean of 105 and a standard deviation of 11. Find the following probabilities to nearest 10,000 and that a randomly selected high school baseball game will last between 90 and 110 minutes. So we need to find both z-scores. So I need to find the z-score for 90. So that's 90 minus 105 divided by the standard deviation of 11. That should be a negative number because of the score being below the mean. So I get negative 1.364. And then we need to find the z-score for the upper number, so 110 minus 105 over 11, which becomes 0.455. So then if we do normal CDF, make the lower number negative 1.364, make the upper number 0.455, we wind up getting a probability to the nearest thousandth of 589. Or about a 58.9% chance. To do the next one with a score of 100 minutes, we would use that as my value, minus 105. Again, this should be a negative z-score. Now notice it says more. So when we do our normal CDF, I want to make the lower number the negative 0.455 and the upper number 10. Remember, 10 is saying that it just keeps going on forever. So this becomes a probability of 0.675. If you're having trouble with the calculator, just Google normal CDF. There would be tons of informational videos that pop up, or just ask me in class tomorrow. It's really not that hard. So if you're struggling with it, I can explain it to you in a couple minutes before class starts. Hopefully this video helps. Hopefully you're doing well on this unit so far, and we're going to keep moving on tomorrow.